Hi friends, welcome to Coordinate, and of course we want now to finalize our first data structure which we've started, which is of course we want to understand what arrays are and the final implementation when it comes to the arrays. So firstly, we want now to understand how the arrays are passed on to a function when it comes to data structures and algorithms with C++. The very thing that we need to understand is when we are passing, of course, the arrays with values as parameters to a function, it is passed by reference only. Not by value, but by reference only. That's when we are passing an array with values to a certain function that contains certain parameters. And when doing so, we don't, of course, use the reference declarator, which is the ampersand, on the parameters of that function. No, we actually omit that we don't show it. And usually also the size of an array is omitted. We don't need to specify or entail the function that it will receive an array of this size. No, that part where we embed the size declarator is actually empty when it comes to the parameters that will hold on to the array that will show up with certain values. Let's now provide, of course, a practical example or an implementation for you to see how this actually happens. So now you can tell that we have a void function, and this function is being called a print array because of course we are dealing with the arrays. The name should be descriptive. Now you can tell that on the first parameter of this function, we've just of course denoted that we are working with an array, though we've not specified the size of the array inside here. Of course, we've not specified that this array coming in is of the size 89 or anything. No. So actually, we don't need to specify the size of the array. Neither have we used any ampersand symbol saying no, this array will work on to that and the like. No, because already we know that the array that's coming in contains values and it will be passed on by reference only. So here down you can tell that we also have a second parameter that will hold on to the size of the array. Of course, the size that will come from the actual size from the many function, which will denote the const value that will be embedded on the array that will come from the many function. You will see as we proceed to the many function. And of course here we are just printing out that and printing down that on line 13, and of course on line 11 we are just telling this that of course the size that will come in is of the entered age groups are and the like. And we've used a for loop for we now to print out the data that will come inside this function from the array that will contain the values coming from the many function. So we've of course specified that int I is equal to 0 because we understand that also the array, the first index will start from 0, and of course I should be less than the size and I should be incrementing by 1. Now print out I. So this for loop will of course now traverse each and every position of the array that will come inside this function. And when we come now to the many function, you can tell that of course we have const int and we have the size which is denoted to 5, and this same size, the variable that's holding on to 5 as the actual size that we want to use for this array will be of course now here as a size declarator, because whenever we see size we are thinking of 5, like the normal issue when it comes to the variables and the like we were learning from the very basic grades of our studies and the like. And then here you can say okay, enter dash, of course size will produce 5, so enter 5 edges, and from there we have now the for loop which of course will iterate in all the very indexes of this array for as long as it is less than the size of the array. So cin edges, and of course we want now to call the function that will now deal with this array from the other function, which is the print array function. So you can tell also here when passing now the name of the function to the array, which will also contain the parameters that will receive these values, you just need to specify the name of the array, because already the program knows that whenever you see edges, these edges, it's the name of the array which we've already worked on. So no need also to specify here that okay, we're passing out this. No need to do this. Why? Because the program already knows that edges is equivalent to the array that we've already specified. And here you can also pass out the size of the array, which will be held by the second parameter of the print array function, which is size. So let's try to run this code and see the output and how these things will work out. So when we run the code, of course, we'll be prompted to enter the numbers, of course, which we've specified as edges, and after that it will go now to the function that will print out the content. So instead of having all this in the main function, we now have made a function that will only deal with the printing out. So enter 5 edges: 34, 23, 11, 90 and 76. So we have the 5 edges, and here your 5 entered edge groups are 34, 23, 11, 90 and 76. So all you need to know on this code is whenever you are dealing with an array that contains values and you want to pass it to a certain function, there is no need to now show the size of the array that will come in. At the same time, there is no need to use the ampersand or the reference declarator when it comes to understanding or to the parameters of the newly created function that will also have a part in dealing with the array that will come from the main function. Let's proceed on our theoretical part of understanding for we to see now what else we need to understand. So now we want to understand how we can search for a value or a specific item inside the array. Don't forget, when it comes to the arrays, at least we need to be searching for a value, to be deleting a value, and to be inserting a value. Now, how do we search for a specific item inside the array? So you can tell that we have an array here which is called list, and you can also understand that this array contains at least 1, 2, 3, 4, 5, 6, 7 elements inside it. So you can of course now have a clear view based on our previous understanding that for we to know the actual size of this array, it's the actual size which is 7 minus 1, which is 6, because an index of an array will always start from 0. So we have 40 at position 0, then we have 20 at position 1, 26 position 2, 93 at position 3, and 57 at position 4, 13 at position 5, and 7 at position 6. But what if we were asked now to search for 26 inside this array? What will happen? Definitely, an array, please get this clearly, an array, when it comes to searching for an item, the searching of an array is based on a sequential search or a linear search, which is all the same, because sequential and linear, they are all going towards one thing. So if we are told now to search for 26, each and every index of this array, the entire array will be checked to see if 26 yes does exist. If 26 exists, then of course code that we implement to search for that specific item, we even terminate and return now the actual index that's holding on to 26. But if we were to search for an item that's not inside that array, then it means from the start to the end of the array, the entire array will be checked. That's what sequential and linear search actually does. So imagine if we were told to search for 10. If we were told to search for 10, definitely we will find that 10 isn't at index 0, 10 isn't at index 1, 10 isn't at index 2, 10 isn't at index 3, 10 isn't at index 4, 10 isn't at index 5, and lastly 10 isn't at index 6. So automatically we will return now the code that will specify that there isn't a value in this array that is equivalent to 10. So definitely that's what happens. So this is the actual code that we can use if we want to do the searching and the like. So of course we have a for loop, and if you don't understand what for loops are and how they work, please check the description below. A video will pop up. You see a certain video that will teach you definitely specifically on the for loops, from of course our basic video on the implementation of for loops when it comes to the fundamental or the elementary part of C++. So now to search for that specific item, we'll iterate each and every index of that array, and we'll be comparing each and every position or index of the array with the same number that we are searching for. For example, in this for loop, we are saying, okay, the for loop I is equal to 0. Of course, we know that previously maybe we would have already declared I to be of type int and the like, and then I should be less than the total number of counts, and I should be incrementing by 1. And then we've embedded an if statement saying if the input, which is the name of the array, I, because I will iterate in all the indexes of this array, since it is a for loop, until it is declared, of course, less than or equal to the count. That's when it will stop. We'll be comparing, of course, that value to each and every index of the input array. So if it finds that, of course, at position 0, the number at position 0, which is array input at index 0, is not equivalent to the item we are searching for, then it will proceed on the next value. If the next value is not also equivalent, then it will proceed to the next value. If now the value at input index 2 is equivalent to the number we are searching for, then it will return the statement element found at index. Of course, we will return the I, the actual iteration that enabled us to find the value that is holding on to the value that's equivalent to the item we are searching for. And from there, we even break the statement for we not to continue this process, because by then we already have found the item we are looking for. Else, if it searches all the indexes of the input array and finds that the number that we are searching for isn't at any index, then definitely we'll proceed on the second if statement saying element not present in an input array. Let's have a practical view on our IDE to see how this also works. So we want to search for an item. So this is an array I've implemented. Actually, we are getting the content from the end user. So int count I, and now enter the number of elements in this array. So enter the number of elements in this array. It's telling the end user how many number of elements do you want this array to hold. Then the end user will enter, of course, C in count, and then we are saying int input count. So count now stands out as the size declarator for this array, and then from there we proceed. Enter count, the actual number of elements that the user inserted at first. Enter, let's say if it was 5, enter 5 numbers, and from there we'll proceed to a for loop that will get content from the end user, and then we'll say okay, for I is equal to 0, because the array will start from the index 0, then I should be less than count, and I should increment by 1. Then C in input, of course, at each and every iteration for as long as I is less than the count, of course, which is the number that the user entered at first, to stand in as the actual size of that array. I'm sure by now you understand, because we've been talking about the arrays for about now quite some time. So here we're just printing out that on the console, and that because we want this text to be in between those words, and of course the \t just for the tab. We want to create some space from the margin, and now we are saying okay, we want a new line, and of course space from the margin. Enter a number you want to search for, because by then the user would have already entered all the values that he or she wants to be inside that array. So now what value do you want to search for? So we proceed now to the for loop that checks, or that now analyzes the entire array for we to see if there is a number that is equivalent to the item that the user is searching for. So we are now saying okay, for I is equal to 0, and I of course should be less than the count I increment by 1, and we're saying if the input, which is the name of the array, I, meaning the I, because we understand the I will iterate until we reach the answer that we need, or until we finalize the entire array. If I, let's say at position 0, is equal to the number that the user is searching for, then elements found at index I, which is the actual index that will hold on to the number that's equivalent to what the user is actually searching for. And then if that doesn't happen, then if it happens, just break the statement, don't proceed with the iterations, because we are satisfied we found the answer. But if that doesn't happen, then proceed to the next if statement saying the element, of course, element not present in an input array. So let's try to learn this program also and see how it's working, how we can search for a specific item inside an array. So okay, let me just zoom. Okay, so enter number of elements in this array. Let's just put 6 elements, and then enter 6 numbers. We have 56, we have 13, we have 28, then we have 90, we have 45, then we have 27. So this is 6. Okay, so now searching for the number. So enter a number you want to search for. Let's try first to search for the number that's not part of this array for we to see how this program is working. So let's search for 90 and 96, since 90 is already inside this array. So of course we'll proceed element not present in this input array. Let's terminate this and go back, then we'll search for the number that's present inside that array. So when we run this, you can tell, okay, enter the number. Let's now put 4. Okay, for it to reduce on the pressure, 36, 13, 24, then we have 78. So we have that. Now searching for the number. So enter a number you want to search for. Let's search for 24, because we know 24 is already part of this array. And when we search for 24, we expect now this program to return the index that holds on to 24. So okay, element found at index 2, and you can of course tell that yes, it is at index 2 because this is at index 0, this is at index 1, and this is at index 2. And then we have 78 at index 3 because the final index, its size minus a 1. Let's proceed now on the theoretical part for we to clearly understand what we are doing and how we can implement anything related to that. So there is another type of an array which we call, of course, a two-dimensional array. Like we said, a two-dimensional array is simply a simplest form of a multi-dimensional array, and it can be visualized as an array of arrays because it involves the rows and the columns. And you can tell that yes, this is how the syntax looks. You can tell that here we have a 0, of course, at index 0. We have 0, of course, which is a column, and then of course at 1, 0, 2, 0, 3. So this is why we are saying it is an array of arrays, because it looks like it's combining a number of arrays. And this is why we are saying it is, of course, the simplest form of a multi-dimensional array, because it is an array of columns and rows. And if we were now to understand how we can implement a two-dimensional array, this is the syntax. We need to specify the data type, and then we need also to specify the array name. What is the name of the array? And we need to now, don't forget, this is at declaration when we want to declare an array which is a two-dimensional array. And we need to specify the total number of rows that we want this array to hold and the total number of columns which we want this array to hold. For example, if we say double, this is a data type, meaning the array we want to make should be holding on to decimal numbers. This is double, and of course cells, that's the name, 10 rows of 5 columns. So let's now see the implementation of this, because we want to understand what's happening. So this is what is happening now from our theoretical understanding. So we've created, of course, a double, that's of course double, a data type, and then the name is cells. Then we want to hold on to 10 rows and 5 columns, of course, which should be equal to that declared array. And you can tell that we of course have 10 rows, because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've specified that this array should have at least 5 columns. So you can tell that the numbers inside each and every row is equivalent to 5, because this is 1, 2, 3, 4, 5. But the same rule again comes back. When declaring a multi-dimensional array, we don't need to forget that the indexes, they start from 0, and the final index is the actual size minus, of course, a 1. And you can see on how we declare these things, because we have this, of course, the curly brace, and then we also have that. You put a comma, and then you have a second column, you put a comma, and then you have a third column, you put a comma, commas at each and every column, unless the final column, because the final column, why do we need a comma on the final column? Here you can tell that we don't need a comma because there isn't any other column that will come in, and then we end that with a semicolon. So what we've done here is this. If we were to now illustrate that on the theoretical part, we've created an array that looks like this one. we've created, of course, the index starting from 0, which is holding on to 10 rows, and of course the column starting from 0, which is holding on to 5 array, and of course the actual size now. So this is what we've created from that program that we have. But what if we were told to search for a certain value? How can we return a specific value? So on line 22, we are returning a certain value. Let's say value at cells of course row 5 and column 3 is, then we want to see out that value. If you were to pay much attention here, we are saying we need the value at row 5 column 3. The index starts from 0. So row 5, this is 0, 1, 2, 3, 4, 5. Now of course the column should be 3. This is 0, 1, 2, 3. So we should see 25.75 being returned as the value that's at that position. Let's try to build and run this program for you to see if it is definitely returning. Yeah, so you can tell that yes, it is returning 25.7 because that's the value which is at that position. And if we were, of course, now to analyze more and to understand more from our theoretical understanding, here you can tell that yes, it's what is happening. So we are getting that content, this value, it's what we are returning when we get the value at position 5 of 3. So this is how we can access the two-dimensional array. But what a multi-dimensional array when it comes to data structures and algorithms? Well, a multi-dimensional array, you can even tell from the definition we gave for the two-dimensional array, you can tell that the syntax is actually similar even to the two-dimensional arrays, because a two-dimensional array was simply the simplest form of a multi-dimensional array. So it is a collection of fixed number of components arranged in n dimensions because it is multi, hence we don't know the actual number of dimensions that it can hold, hence using the n. And the syntax for declaring, of course, a multi-dimensional array, it's simply to use the array name, of course the data type we shouldn't forget, and we now specify the actual number of dimensions that we want that array to hold. And when we want to access, it's the same, the name of the array, and specify the position that holds on to that n dimensions that you want to retrieve, because we are using n because we don't know what actually that would do. Let's proceed on our next session as we now want to introduce another type of data structure which is called a linked list. Here we understand the difference between linked list and of course the arrays and how we can implement a linked list. Please don't forget to subscribe, and you are on Coordinate.